The purpose of this lesson is really an introduction to our upcoming lessons. So here, we won't work too much with calculations. Instead, we'll try to understand the basic overview and then work with a few new definitions. So I really see this as setting the stage for our upcoming lessons. So we begin with the idea of this hypothesis test. Now, the hypothesis test will be the focus of our future lessons, and the purpose of a hypothesis test is to determine how plausible a starting assumption is. We call the starting assumption the null hypothesis. And in terms of notation, we write the null hypothesis as H subscript 0 or H naught. Now let's begin with a common example from everyday life to illustrate our hypothesis test. Suppose an individual is charged with a crime. That individual would then face trial by jury where the individual is presumed innocent. So we presume that the person on trial is innocent unless they're proven guilty. Now, evidence is presented at the trial, and if the evidence strongly indicates that the defendant is guilty, then the jury abandons the assumption of innocence and will find the defendant guilty. In this scenario, our beginning assumption that the defendant is innocent is our null hypothesis. The alternate hypothesis, one that we would come to if we had enough evidence to support it, is that the defendant is in fact guilty. Now, for our class, our textbook uses H subscript 1, but other books might also use H subscript A for alternate hypothesis, so just be familiar with both of those notations. Now, in the same idea of this trial concept, the jury does not know whether the defendant is innocent or guilty, correct? It is just going to make an assessment based on the evidence whether they think the defendant is guilty or not guilty. Because of this, there's a few different outcomes of the trial. Now let's label these individually. If our H naught, our null hypothesis, is true, that means the defendant is truly innocent, and the defendant's innocence is something the defendant knows, and it's something the jury is trying to determine. Now, if our H naught, our null hypothesis, is false, that means the defendant was guilty of the accused crime. And see these two things in red as two possible cases. One if we had an innocent defendant, one if we had a guilty defendant. Now, what the jury is going to do is it needs to make a decision based on the evidence. It does not know which of these is true. Based on the evidence, it will either reject the defendant's innocence by saying that the defendant is guilty, or they will decide to not reject and say the defendant is not guilty. Now let's look in this first case. What if the defendant is innocent? So the defendant is innocent, and the jury, after hearing the evidence, says that they're not guilty. In that case, the jury reached a correct decision where the evidence was a correct representation of the reality. Now you can imagine cases where the opposite could occur, and that would be an error and a tragedy. What if the defendant was in fact innocent, but the jury mistakenly declared them guilty? So we have an innocent defendant, somebody who did not commit the crime. However, the jury says that they're guilty. In this case, there would have been an error in the decision, and this is what we would call a type 1 error. This is when the null hypothesis is true, and yet you end up rejecting the null hypothesis, even though it's a true thing. Now, each of these cases has presumed that the null hypothesis was true. Now let's turn our attention to what could happen if the null hypothesis was false. So now the null hypothesis in this case is false. Let's suppose that our defendant truly is guilty of the accused crime. Well, if the jury ends up rejecting the null hypothesis, so they're rejecting that the defendant is innocent, they're going to declare the defendant guilty, and that in case would be a correct decision because the jury is correctly reflecting that the defendant is guilty. If instead, for our guilty defendant, if the jury does not reject the null hypothesis, the jury would end up declaring the defendant not guilty, and in this case, this would also be an error in decision because it would be calling a guilty defendant as not guilty. So in this case, we have two errors shown. A type 1 error occurs when your null hypothesis is true, but you accidentally end up rejecting it anyways. A type 2 error is when the null hypothesis is false, but you end up not rejecting the null hypothesis, even though it is false. Now, all of this was in the context of what tried to be kind of a real-life example. Let's go through these same ideas, but more so in the notation that we would commonly see with our null hypothesis and alternate hypothesis. So here I have my example. It says, consider the following hypothesis test. And again, right now we're just working with the reasoning of the hypothesis test. In future lessons, we'll actually get into the details of how do you assess whether you reject or you don't reject the null hypothesis. Right now, that work's been done for us. We're just focusing on the reasoning. So our null hypothesis, H0, is that the mean is 100. Our alternate hypothesis, H1, is that the mean is not 100. Now, it turns out, although we wouldn't know this at the time, otherwise if we knew it, we wouldn't even need to make our hypothesis, but suppose the true value is that the mean is 150. Now, in the course of our hypothesis test, we end up rejecting H0. And then they're going to ask us, is this an example of a type 1, type 2 error, or a correct decision? Now, just to clarify what's going on, normally we would not know this information, because if we knew it, why do we need a test about it? But we've been kind of told something behind the curtain. The true value is that the mu is 150. We also know that whoever ran this test ended up rejecting their H0. So they ended up rejecting that the mu was 100. And we've been asked, based on these two pieces of information, is this a correct decision, type 1 error, or type 2 error? Now let's look at our chart to help us understand this. If the true value of the mean is 150, then what do you think about our null hypothesis? Is that true? If the true value of the mean is 150, do you see that our null hypothesis actually ends up being false because it said it was 100? So we are actually, in this case, the null hypothesis is false. Now, whenever we reject the null hypothesis, we're now in this row. And then if we see where these intersect, the null hypothesis rejecting and the null hypothesis being false intersects to give us here our correct decision. So in this case, it was a correct decision to reject the null hypothesis because the null hypothesis was false. Now, one more bit of notation I want to introduce to us. Whenever we're dealing with a hypothesis test and we have the format that when our alternate hypothesis H1 is some mu not equal to some number, this is called a two-tailed test. And we'll see more visualization of what two-tailed means in upcoming sections, but just keep that in mind for now. If you have an alternate hypothesis where you're saying the mu is not equal to a value, then you're dealing with a two-tailed test. Now I'm going to read through this next one, and I want to give you a few moments just to think about it on your own, and then we'll go through it as we did the last one. Consider a hypothesis test. We have our null hypothesis, mu is equal to 18. Our alternate hypothesis is that mu is in fact greater than 18. Now we've been told this extra bit of information. We've been told the true value of mu is actually 20. Now normally we don't have this, but we've been told this extra piece so we can make sense of things here. And when the test was run, it ended up that H0 was not rejected. Now based on these two pieces of information, and our table here that categorizes different types of errors, identify if this hypothesis test and result is an example of a type 1 error, type 2 error, or a correct decision. And I would encourage you to pause the video right now and using this table, think through this. Unpause to check your work. Now, the way we've worked with the first piece of information is if the true value mu is 20, then our h0 assumption that it was equal to 18 is false. So I would be in this column, h0 is false. Now it ends up that I did not reject h0. So whenever you do not reject h0, but h0 was actually false, we end up with a type 2 error here. So this is an example of a type 2 error. And then one more classification. When the alternate hypothesis h sub 1 is of the form mu has to be greater than some numerical value, this is what we call right-tailed. For now, just work on recognizing between two-tailed, right-tailed, and what we'll soon see as a left-tailed. Later sections will deal with this more in detail, but right now you're just associating that if the alternate hypothesis is our mu is greater than some value, we know that that's a right-tailed test. Okay, so here's our next example, set up similarly to the previous ones. It says consider the following hypothesis test. Our null hypothesis is that mu is equal to 3. Our alternate hypothesis is that mu actually should be less than 3. Now it turns out that the true value of mu is 3. And after we ran the test, we ended up rejecting the null hypothesis. Is what's described here an example of a type 1 error, type 2 error, or correct decision? You can use this chart to make your reasoning. I'd encourage you to pause the video right now and attempt this on your own, and then unpause to check your work. Now, if the true value of mu is that mu is 3, then looking back at our null hypothesis, we see the null hypothesis was actually true. So we are in the case that h0 is true. We also ended up rejecting h0, and whenever we reject h0, but h0 was true, we see that we're in a type 1 error. We rejected something that actually was true at the beginning. Now, in terms of classifying this type of test, when our alternate hypothesis is of the form mu is less than some numerical value, this is called a left-tailed test. So in these examples, we discussed identifying type 1 errors, type 2 errors, correct decisions. We also, based on how our alternate hypothesis H1 is described, we can identify whether our test is two-tailed, left-tailed, or right-tailed. Our next example says that a sample of 100 flounder of a certain species have a sample mean weight of 21.5 grams. Scientists want to perform a hypothesis test to determine how strong the evidence is that the mean weight differs from 20 grams. So whenever they say differs from 20 grams, that means is different from 20 or is not exactly 20. Just based on this description, we're asked to state the appropriate null and alternate hypothesis. And we should also describe what type of hypothesis test is here. Is this a left tail, right tail, or two tail? Now, our null hypothesis will always be that our mu is equal to some value. In this case, let's say mu is equal to 20 because 20 is the point we're interested in. We're going to assume mu is equal to 20, and if we have enough evidence, we'll be able to show that in fact, our alternate hypothesis mu is not equal to 20. Because the scientists want to see if there's enough evidence to show that it was different than 20. And the thing that we want to show if we have enough evidence is our alternate hypothesis. Now we know in terms of identifying what type of test it is, you look at the way H1 is described. Because H1 has our mu not equal to a certain number, this would be a two-tailed test. Now, we've talked briefly about conclusions to the hypothesis test, whether we reject or do not reject, but mostly that was kind of in the introduction phase when we were discussing type 1 and type 2 errors. Now we're going to actually state our conclusions for particular problems, and we never just say that that H0 is rejected and we're done. Instead, since our problem dealt with a real-world scenario, we have to describe this idea that the null hypothesis is rejected, the alternate hypothesis is true, and we need to express this in words related to the problem. So let's just say this one more time. If the null hypothesis is rejected, so if we get enough evidence to reject the null hypothesis, then we conclude that the null hypothesis is false and the alternate hypothesis H sub 1 is true. We then express whatever H sub 1 is in words related to the problem, and that is what we have shown to be true. Now, on the other hand, if we instead cannot reject our null hypothesis, then because the null hypothesis is not rejected, we do not conclude that the null hypothesis is true. The null hypothesis being rejected, all that means is that there was not enough evidence to reject the null hypothesis. So the only thing that we can state is that there's not sufficient evidence to conclude that H1 is true. So let's take what we just said in words and break it down into a flowchart. Now this flowchart is not included in our course notes, but there's space off to the side or in the upper corner that you could write this in or in a spare page, and I think it could be helpful for you. So I'd encourage you to pause the video if needed and copy this down. Let's go through this flowchart. So we're going to conduct a hypothesis test. From the hypothesis test, there's two possible outcomes. Either we reject H0 or we do not reject H0. Now, if we end up rejecting H0, then our conclusion is that H0 is false and H1 is true. And of course, we need to phrase that in terms of the problem. Now, if instead we do not reject H0, all we can conclude is that there's not enough evidence to conclude H1, the alternate hypothesis, is true. And we've got to phrase that in terms of the wording of whatever problem we're dealing with. So remember, these are the two possible outcomes for a hypothesis test. Reject, in which case H1 is true. Do not reject H0, in which case all we can say is there's not enough evidence to conclude whether the alternate hypothesis is true. So in our next example, we have the mean caffeine content per cup of regular coffee served at a certain shop is supposed to be 100 milligrams. A test is made that our null hypothesis H0 is that the mu is equal to 100 versus the alternate hypothesis H1 that mu actually is different than 100. It's not 100. After calculations, and again, what are these calculations? That will be a subject of our future lessons, but let's say the calculations are done and it turns out the null hypothesis is rejected. So we reject H0. Now we need to practice stating an appropriate conclusion in context of the problem. So looking at our flowchart, did we end up rejecting H0 or not rejecting H0 based on the problem statement? We ended up rejecting H0, which means I need to state in words that the H0 is false and the H1 is true. Okay? Now, what was this all about? All of this, if we go back to the context of the problem, is that the mean caffeine content per cup of regular coffee was a certain value. Now, our null hypothesis is that it was 100, which was shown to be false. Instead, the mean caffeine content is not 100. The truth of the matter is that our H1 is true, and H1, all it said is it's not 100. So the only thing we can state here that we know for a fact is the mean caffeine content per cup of regular coffee is not 100 milligrams. So the mean caffeine content per cup of regular coffee is not equal to 100 milligrams. So one thing to note here is we did not just say we reject H0 and we're done with it. We rephrased what rejecting H0 is in the context of the problem. Let's practice this in a few different examples. Also, before we go forward, based on how H1 was described, is this a left tail, right tail, or two-tail test? Since our alternate hypothesis is that mu is not equal to a value, that's a two-tailed test. So next up, a veterinarian claims that the mean weight of adult German Shepherd dogs is 75 pounds. A test is made with the null hypothesis being that the mean is 75 pounds versus the alternate hypothesis that it's different than 75 pounds. After calculations, the null hypothesis is not rejected. So since it's not rejected, which part of our flowchart are we in? We did not reject H0, which all we can conclude there is that there's not enough evidence to conclude H1 is true. So we know it's not enough just to say that we cannot reject H0. We have to rephrase it in terms of the problem we're interested in. So let's think. We begin with the statement always, not enough evidence. So we'll start there. There is not enough evidence. And then let's go back to the phrasing of the problem. What did we actually care about here? As we go through the type of the problem, we look and it said mean weight of adult German Shepherd dogs. And then we cared about, was it a certain value or was it not a certain value? So there's not enough evidence to conclude this portion of the phrase we should always write down whenever we end up not rejecting the null hypothesis. And then we make it specific for the particular problem. Not enough evidence to conclude that the mean weight of adult German Shepherd dogs and then it says not enough to conclude H1. So all we can say is there's not enough to conclude this. So the mean weight of adult German Shepherd dogs, mu not equal to 75 here. Not being equal is saying differing from, not that value. So we can say there's not enough evidence to conclude the mean weight of adult German Shepherd dogs differs from .75, and then they use the units pounds. Now we've gone through two of these types of examples previously. I would encourage you to right now press pause on your computer and read through and attempt this problem on your own. After you've done that, unpause to check your work. So pause now. Here we have that a sales manager believes that the mean number of days per year his company's sales representative spends traveling is less than 50. A test was made where our null hypothesis is that the mean number of days traveling was exactly 50 versus the alternate hypothesis that the mean number of days spent traveling was actually less than 50. After calculations, it ends up that we do not reject the null hypothesis. Now we need to state our appropriate conclusion. We know just saying H0 not rejected is not enough. We've got to go back to the context of the problem and also the correct conclusion based on the fact that we did not reject the null hypothesis. Now, if the null hypothesis is not rejected, we know we're in this portion of the hypothesis test, and the only thing we can conclude is there's not enough evidence to conclude whatever H1 was true. So here I'm going to begin whenever we do not reject the null hypothesis, we always start with the same phrase. There is not enough evidence to conclude that. So this first part was just our stock phrase. Anytime we fail to reject the null hypothesis, we say not enough evidence to conclude that. then go back to the problem. What were we trying to show about H1? We were trying to show H1 was our mean number of days per year was actually less than 50. So we write that out, that the mean number of days per year sales representatives spent traveling is less than 50. Now here in our next example, we're told washers are used in a certain application, and for this application they're supposed to have a thickness of 2 millimeters. A quality control engineer measures the thickness for a sample of washers and tests that our null hypothesis is that the mean thickness is 2 versus the alternate that it differs from 2. If after doing the test we end up making a type 1 error, they're asking us what conclusion will be drawn. So what conclusion would result in a type 1 error? Now for a type 1 error, type 1 errors occur whenever you've got a true H0, but you end up rejecting that true H0. So our supposed true H0 was that the mean thickness was 2, but if we end up rejecting that, we would have to say that that's not true. We'd have to say the mean thickness is not equal to 2 millimeters. Now let's look at the next one. It says if instead, so kind of restart, same setup, but now a re-question. If a type 2 error is made, what conclusion will be drawn regarding the mean washer thickness? So what conclusion would have given us a type 2 error? Now I would encourage you to pause the video and think of this on your own, and then unpause when you're ready to check your work. So looking at the chart, I know in order to make a type 2 error, maybe I'll change colors there. Type 2 error can only occur when H0 is actually false, but we end up not rejecting H0. So H0 was false, but we don't have enough evidence to reject it. So here we'd say something like there's not enough evidence to conclude that the mean thickness differs from the supposed 2 millimeters. So a few things that I'd encourage you to add to your notes if you don't already have them. Make sure you've clearly got somewhere this chart that represents when we have type 1 errors, what occurs, when we have type 2 errors, when our hypothesis test results in a correct decision. Additionally, I encourage you to have this flow chart written out that shows us the different results of a hypothesis test when we reject H0, that is telling us our null hypothesis is false and instead the alternate hypothesis is true. And if we fail to reject H0, if we do not reject it, all we can say is there's not enough evidence to conclude our alternate hypothesis is true. So remember, the whole purpose for this section was the setup. In the upcoming sections, we'll actually go through how do we make the calculations so that we can make a decision about rejecting or failing to reject the null hypothesis.